fellow coders. Today we're going to go through an example of a very common type of interview question called the subarray sum problems. The question we have today is, given an array of positive and negative integers, find the subarray with the maximum sum. So the first thing you want to clarify with the interviewer is what is meant by a subarray. And in this case, a subarray means a continuous or contiguous portion of the array. So for example, this would be a contiguous portion of the array. This would also be a contiguous portion of the array, whereas if you just have -2 and -1, that would not be a contiguous portion. And you want to ask what happens when the array provided is empty or is null. And in this case, we'll just return null. And we assume that the array is not empty. This problem only really makes sense if it contains both positive and negative integers, because with only positive integers, then the subarray with the maximum sum would just be the entire array, because that would obviously give you the maximum sum. But with negative numbers, you have to find the portion of the array, including the negative numbers, that gives you the maximum sum. So how do we approach this problem? The optimum solution uses what's called Kadane's algorithm, which states that the maximum up to a certain index I is equal to the maximum of a of I, which is the value at index I, and a of I plus max up to I minus 1. Now what does that mean? Max up to I is really the maximum sum up to the index I. So let's go through that with an example. Let's pretend that I is here. We'll start here at I. And the maximum up to I is equal to max of a of I, which is -2, and a of I plus max up to I minus 1. Well, this doesn't exist because we're starting at I equals 0. So the maximum up to 0 is -2. And then we'll increment I here. And max up to I is equal to the max of a of I. So max 4 plus max up to I minus 1. Now we know it's -2. 4 plus -2. So this is 2. And the maximum between 4 and 2 is 4. So what does that mean? That means that the maximum up to index I is either itself or itself plus the maximum of the previous index. So using Kadane's algorithm, we'll know the maximum up to each index as we iterate through the array. And it turns out that knowing the maximum up to each index will allow us to find the maximum subarray sum of the entire array once we iterate through the entire array. So we'll show you how to do that. Let's go through the example using Kadane's algorithm. We'll start at index I equals 0. And here we can see that the maximum subarray starts at 0, and the maximum subarray so far ends at 0. And the maximum we've seen so far is -2. It's the first number we've seen. And max up to I is also -2. So let's move on to the next element. Here we have a of I equals 4. And 4 plus -2 gives you 2. So the maximum up to I, if you remember, Kadane's algorithm says that the maximum up to I is equal to a of I, which is 4, the maximum of a of I, and a of I plus max up to I, which is minus 2, which the maximum of that is 4. So max up to I here is 4, and that is bigger than our maximum, so we'll update our maximum as well, and we'll update our max end to our max start and max end to 1, because this subarray is the biggest we've seen. The next element is minus 1, and 4 is bigger than minus 1, and minus 1 plus 4 is equal to 3, and you want to calculate the maximum. The maximum of a of I and a of I plus 4, which would give you 3. So max up to I is 3, but it's not bigger than our all-time maximum, so we're not going to update the start and end and the maximum. And we'll move on to the last index, which will give us 2. And we want to find the max of 2, and 2 plus 3, so that's 5. So max up to I is now 5. And we know that max start is at 1 here, and max n is at 3, and max is at 5. So there it is. So 5, this subarray is the largest subarray with the maximum sum in this entire array. So how do we know in that last step why to only update max end and not max start? Well, that depends on this function. If a of I is the maximum, then you would want to update max start. If this part is the maximum, then you will only update the max end. Let's write that in the code and then you'll see. So let's start with the function definition. It's always good to start with the function definition. Public. And you'd want to return the start and end indices of the subarray. So let's say we have a pair class that can take an integer. So we'll return a pair of integers. And let's call it find max sub array. I'll take in an array of integers. So the first thing we want to do is check the edge cases. So if the array is null, or if the array is empty, we'll just return null. And then we'll declare our variables. Max start goes to 0 index, and max end goes 0, and then the max up to I is equal to first element, and then without space here, and then the maximum sum is equal to integer dot value. And this gives you the minimum value possible in an integer. So the first time you find any element that would be greater than the max sum, and you'll replace max sum with that value. And then we can enter our loop for int I equals 0, I less than a dot plus plus. And then in the for loop, we have the Kadane's algorithm, which states that the maximum up to I is equal to math.max, which gives you the maximum between a of I and a of I plus max up to I from before. And then if max up to I, which we've now determined, if that's greater than the existing maximum sum, we'll update the maximum sum to be equal to max up to I, and we'll update the end index of the maximum subarray to I. And we have one more if statement that states that if a of I is in fact the bigger of a of I and a of I plus max up to I, then we also have to update the start index to be the current element at I, basically. So the index of the current element. And finally, we'll return a new pair of integers with the start and end indices, and that will give us the maximum subarray. And that's it. If you guys found this helpful, please like and subscribe, and if you have any questions that you'd like to be explained in the video, just comment in the comment section below. Have a good day.